All right, question number 13. I'm going to use the graphing guidelines to make a graph of the function. All right, again, we have the answer choices, so we'll simplify as much as we can. X minus 2 times cosine of x. And we have our domain. Domain is from negative 2 pi to positive 2 pi. All right. One of the first things I want to do is find the derivative, and we're going to find decreasing intervals and critical points. So we're going to find f prime of x. Derivative of x is 1. Derivative of cosine is going to be negative sine. So this will be a negative sine x. All right, simplifying this, we'll get 1 plus 2 sine of x. All right, so here's our derivative. We're going to set this equal to 0 and find our critical points on the interval negative 2 pi to 2 pi. Subtract 1, we'll get a negative 1 equals 2 sine of x divided by 2. We get a negative 1/2 equals sine of x. Now you can do inverse sine. However, what I'm going to do is I'm going to take you to the unit circle. So on the unit circle, let's say if I draw it, there's going to be 2 points where we're going to get a negative sine of 1/2. On the top, sine corresponds to the y values. Sine will be positive on the top, negative on the bottom. We should be looking at these two ordered pairs, which should be 7 pi and 11 pi. Okay, but I'm going to show you that on the unit circle and verify. So those are going to be our critical points. Go back to our course. We're going to go to our cheat sheets under the videos tab. And then we can do our trig cheat sheet. Alright, having a little issue. Let's see if it refreshes. Just thinking about it. Alright, here we go. Alright, so on the unit circle, which is on the second page, we are looking at the ordered pairs where y is negative 1/2. And so you see the ordered pair negative square root of 3 over 2, x, and negative 1/2, that's the y, 7 pi over 6. And then over here on the other side, at 11 pi over 6, we get square root of 3 over 2 and negative 1/2. So I didn't put my denominators on there, but over 6 over 6. And those are going to be the two x values in the range. Now that's just positive 2 pi. So if I was to go backwards, because we got negative 2 pi to positive 2 pi, I got to get 2 more critical values. So we got to think about going around the unit circle backwards. So if we go backwards, all the ordered pairs are reversed. It starts negative. So this first point, instead of being 11 pi over 6, it would be negative pi over 6. So let me write the positive ones first. 7 pi over 6 and 11 pi over 6. Now if we go backwards, because we're going also to negative pi, this first point corresponds to pi over 6. It's like if you were to take this circle and just kind of invert it, and you would be going backwards, but there'll be negative values. So negative pi over 6, and then this will be negative 5 pi over 6 when you got to this point. kind of like this point, just mirror image across. So negative pi over 6 and negative 5 pi over 6. So these would be our critical values. I've written them down. All right, so now we're going to do our test for increasing, decreasing intervals. That will let us know if there's a local maximum or minimum at each of these points. And then let's just put 0 in the middle. Negative pi over 6. Then let's just say negative 5 pi over 6. And then over here we would have a positive 7 pi over 6 and 11 pi over 6. So that kind of runs off a little bit. Okay. So from here, we want to know if it's positive or negative. What I will do, I won't graph the whole thing, but I'll do one of them by hand. So let's just say if I put in a negative pi to test, negative pi is going to correspond to this position, which is negative 1, 0. So starting with our f prime, it's going to be f prime of negative pi. That will give me 1 plus 2 times sine of negative pi. All right, so sine of negative pi is going to be equal to 0. So this is just going to be equal to 1 plus 2 times 0, which is just equal to 1. That's positive. So I get a positive on this section. So between negative 2 pi and negative 5 pi over 6, we are increasing. All right, and then if I pick a value between negative pi over 6 and 5 pi over 6, let's just pick this angle right here. This will be negative pi over 2. Do the same thing, f prime of negative pi over 2 would give us 1 plus 2 sine negative pi over 2. Negative pi over 2 is going to correspond to this ordered pair, which is x is 0, y value is negative 1. So this sign would become negative 1. So I have a 1 plus 2 times negative 1. And that's a negative 2 plus 1, which gives me a negative 1. So we get a negative here, so it's going down between negative 5 pi and 6. So we're getting that this is a local maximum, and we're going to continue to do the same thing for each of these functions. So some of these values I don't have exact trig values for, so I'm going to use a calculator to help us out on some of these values. I am just going to plug in the derivative, so I'm not going to actually do the original function. I'm going to plug in the derivative. Derivative is 1 plus, minimize this so I can see more of the calculator on the screen. 1 plus sine, 2 sine of x. All right, so I'm going to graph just this function. I'm going to click trace. And so I'm going to pick some value. So I don't have a trig value that's between, or I do. I could just pick 0. I was thinking between pi over 6 and 0, but 0 is not a critical value. So I can pick anything. If I pick 0 pi, we get the y value is 1. That's positive. So this section is increasing again. And then if I pick a value between 7 pi over 6 and 11 pi over 6, let's say 7 pi over 6, we can pick 3 pi over 2. If I do 3 pi divided by 2, and I'm picking these values based on what's on the unit circle, so I'm not looking at the unit circle, but if you have it committed to memory, you can kind of recall some of these values. Hard to read that, but that's 3 pi over 2. Let me make it big and zoom in. So I'm picking values that are easy to work with as far as the order pair. 0, 1s are always great. 3 pi over 2, that's the one I was referring to. It's going to give me a -1 again. But I'm not plugging it in. The calculator's doing that for me. So when I do 3 pi over 2, I should get a negative again if everything works out correctly. And we get a -1. So from increasing back to decreasing again. And then if I look at between 11 pi over 6 to 2 pi, that's one that I don't have. So I'm going to just take this 11 pi over 6, add it to the 2 pi, and just find the midpoint. So I'm going to just say, take these two, add them together, and divide by 2. And that'll give me a midpoint. So I want to do second. I'm going to just do parentheses. I'm going to say x is going to be 11 pi divided by 6 plus 2 pi. And then this whole thing is going to get divided by 2. So you got to tell it to do all this first together and then find the midpoint. So that's going to give me the midway between those, and that is a positive value. So it starts increasing again on this slope. So we have a local max, and then we have a minimum here. We have a max, and then we have a minimum, and then it ends at 2 pi. Okay, so let's look at the answer choices and see if we can kind of eliminate some potential candidates. So we are between -2 pi and -5 pi over 6. We're going to be increasing. So we start out increasing, and I can kind of see that over here. This graph is decreasing. I would eliminate it. Looks like this one is kind of increasing. I would eliminate it. This one is increasing. So I'm going to be looking at C and D. Now, if I want to zoom in a little bit more to try to pick those points, we had a maximum first, we had a minimum value, and then we had another maximum, and then a minimum going into the 2 pi, which that looks right, max, min, max, min. That follows the correct pattern. And then here, max, min, max, min. So both of these look pretty close. Now we just really need to determine which one is more accurate, because this one kind of crosses the x-axis. So I can just really plug in a point now and see if I plug in 0, do we get 0 or do I get a different value? So that's going to be the deciding factor here. Now you can do second derivative tests, look for concavity and all those things, and that'll help you. But this might simplify it a little bit because it's already a long process. So I'm going to take the original function, and comparing these two graphs, which I think we've isolated to a 50-50, we're going to plug in the ordered pair 0, or plug in the x value 0 and see what our corresponding y value is. So going to our original function, we're going to find f of 0, just plotting a point. Easiest way to graph a function is plotting points. Plug in 0 for x. This is going to give us 0 cosine of 0. So the 0 is here, 0 pi radians. Ordered pair is 1, 0. So this is going to be a 1. This is going to be, -2. Cosine of 0 is just 1. It is 1. So -2 times a 1 is -2. So we're getting a -2 when I plug in 0. That would correspond more closely to graph C. If I'm looking at the labeling, I don't see a y-axis, I just see a 10. Okay, so looks like if these counted by 2, 4, 6, 8, 10. All right, now I'm gonna do one more thing. I'm gonna go to the graph, and just so you can verify, like if you have the graphing calculator, it's online free. You can type in the original function and you can see it, but you do want to know some of the basic properties and things that you can work by hand when this isn't available or when you want to do it by hand. Now, also, if you look at this window, it goes from positive to negative 10, and the domain goes from negative 2 pi to positive 2 pi. So I'm not going to change all of the window, but if I go to window, I do want to make the x minimum negative 2 pi and the x maximum positive 2 pi. And then the x min and max are already 10. So it'll give me more of the graph that we're seeing. And so we see that shape, okay? And that looks pretty close to what we're seeing here. All right, so we're saying C is our best fit graph.